Welcome back, students. So, in this video, we will discuss the rules to draw ray diagrams for spherical lenses. Here for mirrors, we studied 4 rules. The same way, for lens also, rules are there to construct the ray diagrams. Here for mirror, 4 rules are there. In case of lens, 3 rules are there. With the help of any 2 rules, you can construct the ray diagrams. Okay. So, first we will discuss the rules. After that, we will draw the ray diagrams. Okay. So, just like in mirror, we will discuss the rules for lenses and we will draw the ray diagram. This is the first rule. Ray of light parallel to the principal axis, after refraction, it will pass through the principal focus. In case of convex lens, and it appears to come from the principal focus in case of concave lens. So, it is a convex lens. This one is the principal axis. I told you 2 principal foci will be there for lenses. Normally, it is represented by the letter F1 and F2. So, ray of light parallel to the principal axis, after reflection, it passes through the principal focus on the other side of the lens. On the other side of the lens. For concave lens, a ray of light parallel to the principal axis, after refraction, it appears to come from the principal focus on the same side of the lens. On the same side of the lens. Once again, a ray of light parallel to the principal axis, after refraction from a convex lens, it passes through the principal focus on the other side of the lens. Means on the right side of the lens. A ray of light parallel to the principal axis, after refraction, it appears to come from the principal focus on the same side of the lens if the lens is concave. If the lens is concave. Now, I will draw it for you. It's a convex lens. When you draw it, you have to draw very thin lens. First, you need to mark the optic center. Here F1, here F2. This distance from O to F1, you can take it as 2 cm. Normally, we will take it as 2 cm. From this O to F2 also, we will take 2 cm. Okay. The distance between O and F1 and O and F2 is same. So, normally we will take 2 cm. Now, this one is the principal axis. I will represent it as PA, short form. Ray of light parallel to the principal axis. Here also you need to draw the optical axis by dotted line. So, a ray of light parallel to the principal axis. A ray of light parallel to the principal axis. From this optical axis, you need to show the bending. Okay, you need to show the bending from this optical axis. It passes through the principal focus on the other side. On the other side. When you draw it, don't draw it like this. Okay, don't draw it like this. From the optical axis, you need to bend the light rays. Okay, like this. Mark the optical axis. From here, you need to draw the bending. Okay. Now we will draw it for concave lens. Thin lens you need to draw. Mark the optical axis, optical center. This one is F1, this one is F2. Ray of light parallel to the principal axis. After refraction, it diverges. So you need to backtrace this line, and that backtrace line normally we will use dotted lines, and it appears to come from the principal focus on the same side of the lens. That is the first rule. Second rule is the reverse of the first one. Second rule is the reverse of the first one. That is, a ray of light which is passing through the principal focus, after refraction, it emerges parallel to the principal axis. A ray of light passing through the principal focus, after refraction, it emerges parallel to the principal axis. This one. A ray of light parallel to the principal focus, after refraction, it emerges parallel to the principal axis. A ray of light passes through the principal focus. It appears to come from the principal focus, or it appears to travel through the principal focus. After refraction, it's parallel to the principal axis. This one is the principal axis. So, after refraction, this ray is parallel to the principal axis. That is second rule. So, in your textbook, page number 179, mark it. A ray of light, three rules are given as 1, 2, 3. A ray of light from an object parallel to the principal axis after refraction from convex lens passes through the principal focus on the other side of the lens. In case of concave lens, a ray appears to diverge from the principal focus located on the same side of the lens. Second rule, a ray of light passing through the principal focus after refraction from convex lens will emerge parallel to the principal axis. A ray of light appearing to meet at the principal focus. A ray of light appearing to meet at the principal focus. This ray. After refraction, it emerges parallel to principal axis. That is a second rule. Okay, that's a reverse of the first one. Then one more rule is there. That is a third one. A ray of light passing through the optical center will not suffer any deviation. A ray of light passing through the optical center or optic center will not suffer any deviation. A ray of light passing through the optic center will not suffer any deviation. That also you mark it there. A ray of light passing through the optical center of a lens will emerge without any deviation. A ray of light passing through the optical center will not suffer any deviation. Refraction will not take place in that case. Yeah, actually if you draw very thin lens, then refraction will not take place, means we will neglect it. Actual diagram I will show you. In normal case, that is in case of thick lens, an incident ray will be parallel to emergent ray. Incident ray will be parallel to emergent ray. It will suffer lateral displacement, but incident ray will suffer lateral displacement. In case of thin lenses, that lateral displacement will decrease. When the thickness of the lens decreases, the lateral displacement also decreases. Here, this one is a incident ray, this one is a emergent ray. The incident ray and the emergent ray are parallel. However, the emergent ray is laterally displaced in case of thick lens. In case of thin lens, as the thickness is decreasing, the lateral displacement also decreases. The lateral displacement also decreases, and for thin lenses, when a ray of light passing through the center of curvature will not suffer any deviation. This one also you need to mark in your textbook. Rule 3. A ray of light passing through the optical center of a lens will emerge without any deviation. So, 3 rules are there for the formation of image. With the help of these 3 rules, we can construct or we can draw the ray diagrams. Okay, just like in mirrors we did, in the same way we will do it in the next video. Okay, when you draw this ray diagrams, you have to draw with pencil and scale. And one more thing, when you draw the lens, you have to draw thin lens, means a lens like this. Okay, very thin lens you need to draw. Okay, thank you.